Hello everyone, thank you for clicking on this help video. So if you're watching this, then you're getting stuck on this problem and are getting this one wrong. So let's see if I can help you out with here and find again what errors, you could find what errors you're making. So in this example, we have that a scientist is going to start with 20 grams of a radioactive substance and it's going to decay continuously at a rate of 9% per year. So how many grams of the substance will be left after 10 days? So we have to first be able to figure out what is the formula we need to use here from the three that we talked about today. So we have the continuous one, the compounded one, the regular exponential one, that's RT, not NT, T, okay? And then we have the continuous one, and the continuous one works the same for both compounding and just regular, normal, continuous growth or decay. Now, in order to decide which of these three we're going to have to use, we'll look at what keywords we have here, what hints we have. It says that we're going to decay, so that's going to decrease, so that's definitely not compounding. This one is out. Because decreasing doesn't, decreasing doesn't go with compounding. That one is always increasing. The value of R is always going to be positive. So that leaves us these two. And because it says continuous here, then it has to be these continuous ones right here. And again, doesn't matter which version, they both do the exact same thing. A and P are the initial amount. One is just called principal, the other one is just amount. Doesn't matter what amount we're talking about. So we're going to use this formula here. So let's see. Since we're not talking about money, let's ignore that one and let's just stick with this version here in terms of the variables. So A is the initial amount that we're going to start off with, and the scientist in my version starts off with 20 grams. The interest rate in my version is 9%, and it's decaying, so that's going to be a negative number. So negative 9 out of 100, which is negative 0.09. And T is 10 days. And since our decreasing rate is 9% per day, and we're measuring our time in days, those units match. So we don't have to do any conversion of neither of those two numbers. All we have left to do is plug it in and evaluate. So 20 times E raised to the negative 0.09 times 10. Let's see what we get from there. We need exponent. There we go. We didn't type in the exponent, 0.09 and times 10. That's going to be 8. So the amount of this radioactive substance is going to decrease all the way down to 8 points. We want to approximate to 1 decimal place. So 1, 2 decimal places right now. And since we want to estimate to this 1 decimal place, I have to look at immediately to the next one, the one after that. And since this is not 5 or more, I don't have to add 1 more. So it's going to stay to 8.10. So 13 is closer to 10 than it is 20. So 8.1. And there's your answer. Okay, so I hope this video was helpful. And now try your version of this example.